viewers, and welcome to another episode of Space Science with Python. In the past, I covered already two tools. Besides Python coding, I also covered the NASA Horizon system and also the planetarium software Stellarium. So you see it also here on the bottom, and we also use it frequently for our coding sessions, like last time where I was talking about the ecliptical and the equatorial coordinate system. Now today, I would like to introduce you another online toolkit that can be used, and its name is Heavens Above. Now, Heavens Above is you see quite simple website where we can visualize different satellites, astronomy, appearances, and so on. So, for example, you can determine the 10-day predictions for satellites of special interest, like, for example, the International Space Station or the Tiangong Space Station, and so on. So this tool computes you the coordinates, the appearance times, the maximum height of the object, as well as also the brightness. So with the brightness, you can also determine whether you can see the object or not. And also, some other miscellaneous stuff we will not cover. Before we dive into this application a little bit, we have to change our location first. So either you can create a login or you just set up the location manually here. Now here is Bristol, but I'm not living there. So let's search for my current location. We can also add the what 3 words or latitude, longitude values and so on. But let's just make it simple and search for Stuttgart. Now this is not the exact location where I'm living, like where is it actually? Probably the center of the city. I'm living a little bit outside, but a few kilometers plus minus is okay. So we can use this one and create update. Now also the elevation is also not 100% correct. I think here is something like, I don't know, 150 meters or so, but that's okay. We can update it, and now we have our location. And based on the location, we can now create like a live sky view. As you know it, we did it already with Stellarium, or we did it also already with Python. On Python, we did it quite simple without any stars. But yeah, you see here the current night, not the night sky, the day sky actually, and also some satellites that are cruising around, like a few Starlink satellites, some Cosmos rocket, and so on. So this is like the current view that you can use to determine live where these objects are. And also here you see the magnitude, so the apparent magnitude of the objects. And the apparent magnitude is, the larger the number, the more difficult it is to observe the star. So like a number like 4.1 or 5, it's quite faint, I have to say. So if you're in the middle, if you live in the city or so, it would be quite difficult to observe an object that faint. But we will cover the apparent magnitude also in one of the future tutorial videos. Now, more interesting is the International Space Station, because that's a satellite we can observe even from light polluted areas quite easily, because the magnitude is quite low, so it has even a minus value. And the minus value is like a very, 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 very bright star. So you will definitely see this with your naked eye. And for example, we can take a look here for my location when I'm able to see the International Space Station. So for example, for today, the 13th of October, when I upload the video, it will be a few days later, but it will just then update accordingly. Now let's see. Okay, it was already this morning. I think here it was almost around sunrise. So 7 o'clock was the first appearance. So this is where it started at an altitude of 14 degrees. So over the horizon. It's not really, it's very, very close to the horizon. Probably also covered by trees or other buildings. And the appearance was in west-northwest. So yeah, you have to know, of course, with maybe with a compass, or you know it by yourself, where this location is, the direction. And 2 minutes later, the ISS reached an altitude of 50 degrees, so quite high over the horizon. I shouldn't click. And in the northern direction. So yeah, I know very well where north is. So if I would have been already up this morning and I would have known it, I would have seen the International Space Station quite bright, minus 3.3 magnitudes. This is really bright. And then with a maximum brightness at or the highest point in northern direction, and then going down at east-northeast, fainting slowly and then disappearing. Now this is how I see it, how I can observe the International Space Station. So now it's currently mostly in the morning hours, so there's not really covering in the evening. I can increase the search period a little bit, and here on the 18th of November, I could observe it. 11 degrees over horizon, also quite low. But yeah, this looks a little bit better here for me. End of November, I can then track the International Space Station. And speaking of this, I think it would be quite interesting to recompute this. So I will create a coding tutorial end of November about this ISS pass. So yeah, you can take a look at the end of November how to compute this with Python. Now, if we go back to today, 13th, yep, we can just click on the appearance, and then we have a sky map. Not a sky map like we did it with the with Python, where we use the ITOF projection. Here it's just a circular projection, and then we see, okay, here is north is here on the top, south is here, and then we have west and east, and then we see where it appeared, and then where the maximum was, like I think 7:14, and then it vanished at some point. So yeah, you can download it, and of course this is quite helpful because 50 degrees over the horizon north whatsoever, it's quite difficult to imagine. But maybe you know some constellations, like for example Ursa Major, yeah, like the bear, and then you can orientate a little bit, and then you see maybe Cassiopeia, the W in the sky, and this helps a little bit to orientate a little bit. And yeah, the times are quite precise. So the idea is always to not look around with your eye, because your eye is, let's say, sensitive to movement. So you just look into one certain direction and try to concentrate what's in your field of view, and then you will recognize some bright dot, and then you can cover or track it easily. So this is always interesting when you observe these things with other persons. Somebody sees something, and it's really difficult for someone to point into the direction, like with a finger, there it is, or so. It's more helpful to say, okay, look at, for example, Cassiopeia, and then try to concentrate. There's a movement below Cassiopeia or so. Yeah, so it's quite interesting how the perception of the human works. But yeah, I'm not an expert in this. It's just my experience with that. So you can download this map and then see. You see here also some other parameters, the distance to your location, the brightness, and so on. So this is quite useful if you are interested in observing the ISS. Also the ISS, you can search for all passes, and it's you see here some are visible, some are not visible, because sometimes in the night the sun doesn't illuminate the ISS, or in broad daylight it's quite difficult to observe it at all. Now let's go to heavens above. The same thing applies also with the Tiangong station. Yeah, here it's like a few days. It's also fainter, magnitude of 3. So you should be more like in a rural region, and you have to know what you're looking for. So I recommend starting with the ISS, for example. Same also with the Hubble Space Telescope. I think it's also quite faint, and for me currently not visible at all. Yeah, so just play around a little bit, right? It's not only about the ISS, also other bright satellites can be seen that are updated regularly with the brightness magnitude. And again, just remember, a smaller number corresponds to a brighter appearance. So you see the night sky, it's quite crowded already. You see almost, if you're in a darker region, almost all the time some kind of movement in the night sky. We have also other features here, like the satellite database with all the satellites and their orbit and so on. So feel free to go through it. We will also cover satellites in the future when we start doing some more programming with orbits. And also we will also try to reconstruct with Python this kind of plots where you see the Voyager 1 and 2 or the Pioneer probes as well as the New Horizons where they currently are. Yeah, so this is the outer solar system. The green dot is Saturn. And then we have Uranus, Neptune, and Pluto. And you see here New Horizons was passing by Pluto a few years ago. And this is like a top view. This is like a small side view. And there you see where all these probes are currently flying, what is the distance to these objects, as well as the speed relative to the sun. And if you follow my Python tutorials, you will see that, well, we can compute this thing with the spice kernels, right? So we download our kernels for Pioneer or Voyager, use the ecliptic coordinate system, and then we can easily compute the distance from the sun, the speed, the ecliptic latitude, and also the distance from the Earth and all these things. So all the table you see here, we are actually now able to compute this, and I think this is pretty amazing, considering that what you can do with Python and just a few libraries, right? The same thing applies also for the height of the ISS. We just need to take the kernel of the ISS and we can compute also this profile here, where you see the height of the ISS, the mean height in kilometers, versus the time. So here it starts October 2020 to October 2021. And then you see this quite interesting profile. You may say, wait a second, the ISS is flying down. Well, even at 400 kilometers, you have the exosphere. So this is just very, very, very thin atmosphere. Most people say, yeah, the space begins at 100 kilometers, but why should it start there and not at 200, right? It's just an artificially set limit or border that is accepted internationally, but the atmosphere of the Earth itself extends way beyond 100 kilometers. It's very thin. Of course, you couldn't breathe, and you would probably, no, not probably, you would freeze to death, and you wouldn't have any air to breathe. But the remaining pressure, the remaining particles are enough to cause some kind of friction that leads to a continuous descent of the ISS. And consider how large the ISS is. You can compare it with a football field. You see that, let's take an example. For example, here, end of January until mid of March. So we have like almost 1.5 months. The ISS dropped by around 500 meters. So it's not a lot, of course, sure. But if we would neglect this, this would get worse and worse. And of course, if you fall down, the density or the atmospheric density increases, and then this falling would also accelerate in a way. So what they do is they push the ISS up regularly so it won't crash with our home planet. And this is also something we can compute with SPICE and the corresponding ISS kernels. Now, we have also some astronomy sessions here. I mean, just play around, look around what you can do with interactive sky charts and so on. I think this may take some time to load. Hopefully this, hopefully it's not crashing, but let's leave it here in the background. Also some data for the sun. Remember, we did it last time where we computed the position of the Mars and the sun in ecliptic coordinates, right? Also the right ascension and declination. We did this, yeah? We also computed the distance to the sun. So basically we could, now this sounds a little bit arrogant, I mean, I have to be careful now. We could, let's say, reproduce or rebuild this website partially with the knowledge we already have. So it's just about, then web development, of course, and then creating this such a website and some images. But theoretically, the backend, we could provide values for the backend. And I think this is pretty amazing. Again, altitude azimuth is something we will cover in the future, because yeah, we know how to compute equatorial coordinates, but we need to consider the horizon because we also want to know when an object disappears, so we cannot observe it. So yeah, this is here for the sun, and the same thing also, yeah, for the moon and so on. So basically the same thing, also the phases. Phases can also be computed with SPICE. So let's cover this in the future. And in the future, we will also cover comets and asteroids. And here we see a lot of comets with their brightness. And as you already know, as already told, a large magnitude corresponds to a very faint object. So magnitude of 14, you have no chance to see it with the naked eye. You need a larger telescope, you need a dark area, you need a certain exposure time, and then you may see something. And you have also to consider that comets are active only when they have a certain minimum distance to the sun. So they're not active all the time. They have to heat up, and the heat corresponds, of course, with the distance to the sun. Now we have also here some asteroids, but only a small part here with some brightnesses. There are 10 or 100,000 of asteroids, a lot of near-Earth objects that come very close to the Earth. But also this will be covered. I already prepared something where we will consider this one. Yeah, I think this is basically the quick introduction. Let's see the interactive map. Yeah, again here we have something like Stellarium, but in the but online, where we now can create, yeah, move the days, move the hours, see how the night sky changes. It's quite interactive. So it's like Stellarium, but in an online portal where we then can print it out. Quite helpful, let's say, if you have only paper, and if you don't want to take your laptop outside in the night, you just want to have some paper to get an understanding of the night sky. I highly recommend using this, because at the end of the day we can compute everything with Python, but going outside, take a look at the night sky, get an idea of the constellations, is something that you only get with experience really out in the field. Yeah, I think this is all for Heavens Above. Again, a quite small tool, but quite helpful if you would like to see the ISS, or if you saw some bright appearance, and you can also cross-check what it maybe was. And I hope you enjoyed this very small introduction into Heavens Above, yet another tool for space science that is maybe not that commonly known for everybody. And next time we will dive into the coding again. We will see how we compute the horizon, and with more knowledge and a larger fundament of the space science topics, we can at some point also create our own website or start doing some scientific insights. Yeah, I hope you liked it, guys. I wish you a very nice day. Take care and goodbye.